We made it, you guys. Lesson 12.2, problem solving with right triangles. It's our last video. Our objective for today is to use trigonometry to solve application problems. A plane flying at 31,000 feet begins its descent 660,000 feet from the airport. Find the angle of depression. So they were kind enough to give us a picture for this one. We can see where the airplane is here, and we can see where the airport is. The angle of depression is talking about this right here, but we actually would have alternating interior angles here and here. So if we can figure out what this angle is, we'll know this because they are the same. It says that it is up at 31,000 feet, the plane is, so from here, from the ground up to here, it is 31,000 feet. It also told us that it began to go down, so the plane starts going down when it is 660,000 feet from the airport. Airport is here, it starts descending here. It's actually talking about this straight distance from when the plane starts to go down. Now that we have all of our information on our triangle, we can start to label it. I do want to note that right here, this would be a right angle with the ground to straight up to where the plane is. This is the angle we are trying to find. So if this is our angle, we go straight across. That's the opposite side. We are going to use that side because we do have information there. And then we look for the right angle, go straight across from that. That's the hypotenuse. No information given there, and we're not asked to find that, so we're not going to use that side. And then what we have left over is right here, that is adjacent. We will be using that side because we have information there. So now if we look, we will be using O and A. So let's write out our SOHCAHTOA. SOHCAHTOA. Might seem silly, but it's helpful. Alright, and we are using O and A. The only one that has O and A is TOA. So that's the one we're going to use, TOA. Alright, so tangent of our angle, which in this case is x, so tangent of x equals, it says OA, it's opposite over adjacent. The opposite is 31,000. And A, which is adjacent, is 660,000. Alright, now we need to solve for x. We want to get x by itself. So to do that, we take the inverse tangent on both sides. Again, if you want to write that out on both sides to remind you what you're doing, that might be helpful for you because we do it on both sides. So then x equals the inverse tangent of our fraction. We go ahead and type that in our calculator. And x is about 3, and this is degrees. And we know it's degrees because if you remember, it asked us to find the angle of depression. So this right here is 3 degrees, and so is this. Juanita used a clinometer, which is an instrument to sight the top of a building, and got an angle measure of 62 degrees. She is 5 feet tall and stood 35 feet from the building. About how tall was the building? So looking over here, we see that she is 5 feet tall, standing 35 feet from the building, and when she holds that device up and looks, she can see that this angle from here to here, so to the top of the building, is 62 degrees. We can figure out what x is right here. But once we find x, we need to use that information to find out how tall the whole building is. So whatever x is, we still have to remember to add on how high up the device is from the ground, which is 5 feet, because that's how tall she is. So we'll get our answer and add 5 to it, and that will be our final answer, what they're asking for. Let's label the triangle. This right here is our right angle, and our angle that we're talking about is 62 degrees. So from that angle, we go straight across. That's the opposite side over here. Go to the right angle and go straight across, and that is our hypotenuse. Looking right away, I can see this is x, so I'm going to want to use this side. I have no information on the side containing the hypotenuse. The side left over is adjacent, which if you notice, this distance here and this distance here are the same, so this is actually 35 here. So we will use that side. And if we look at our SOHCAHTOA, let's see. We for sure want to use O because that's what we're trying to find. And we want to use A because that has information. So O and A, that will be tangent. So we're going to use TOA. We can go ahead and set this up. The tangent of our angle, which is 62, equals opposite, which is x, over adjacent, which is 35. If you want to just balance and solve from here and multiply by 35 on both sides, you totally could do that. Otherwise, if you want to use cross multiplication, we can make that into a fraction. And then we cross multiply and solve. X times 1 is just x, which equals tangent of 62 times 35. Make sure you keep 62 in parentheses. And then x is about, type that in the calculator, 35 times tangent of 62 should give us about 66, but we're not done here. We actually are looking for this whole thing right here. We could go ahead and call it y, and we know y is equal to what we just got, 66, plus this distance over here, 5. So y equals 71, and this was feet. A 20-foot ladder is placed against a wall at an angle of 50 degrees with the ground. How far away from the base of the wall is the bottom of the ladder? Well, I think it would help to notice that this is a ladder. So let's make it look like a ladder. Alright, so we have our ladder, which they told us was a 20-foot ladder. And that ladder makes an angle with the ground. So the angle with the ground would be right here that they're talking about. And that is 50 degrees right there. And then, let's see, this would be our right angle. Let's go ahead and label the triangle with our SOHCAHTOA. Alright, look for the angle we're using. It's right here. Straight across from it is the opposite side. And then we look for the right angle. Straight across from that is the hypotenuse. I do want to use that side because it has the 20. And then lastly will be the side down here, which is adjacent. And we do want to use that side. So it looks like we will be using A and H. We don't need to use O. It didn't give us any information. It didn't ask how high up the ladder is on the wall. It said how far away is the base of the ladder. So the one that uses A and H is Ka. So that is what we will use. Alright, so cosine of our angle, which is 50, equals A, which is x, over h, which is 20. And then you can just multiply by 20 on both sides, or you can make it a fraction and cross multiply. So x times 1, x equals cosine of 50 times 20. I write it like this instead of writing it as this. Let me just show you. So if you don't have the parenthesis there and you put times 20, your calculator will do 50 times 20 first and then take the cosine of that. So that's why you gotta be super careful that you use your parentheses. So if you type that in your calculator, 20 times the cosine of 50. That should give us about 13 feet. So the next three problems here are actually going to be the problems on your warm-up. I'll help you set the three of them up, but then it'll be up to you to finish them. Dennis sights the top of a rocket at 54 degrees when he stands 65 feet away. He is 6 feet tall. How tall is the rocket? Alright, so he's 6 feet tall. We're actually trying to find this right here, y, so whatever you get for y will be your answer, so keep that in mind. Okay, you want to find this right here. This is our right angle, and if this down here is 65, then this right here is 65. And we need to figure out this part, what x is first, before we can find y. So if I label this, this is the angle we're using, so I go straight across is the opposite, and then across from the right angle is the hypotenuse, and then left over is adjacent. So looking at that, it looks like I want to use O and A. So you want to use whichever one of SO, CA, or TOA uses O and A, and then figure out what x equals, and then once you get your answer, don't forget that he is 6 feet tall, so you have to add the 6 on to get your final answer, y. A straight water slide makes a 40-degree angle with the surface of the water. So this is the surface of the water. And this is our super fun slide, right there. If the slide is 11.5 meters high, this is how high off the ground it is. How long is it? So you want to find out how long the slide is. And then this would be 90. See, and we're missing our angle. It says the water slide makes a 40-degree angle with the surface of the water. So that's right here. The slide to the water is 40 degrees. And then go to the angle, which is 40. Straight across from that is the opposite side. And we have a number there, so you're going to want to use that side. And then we look for the right angle, go across from that. That's the hypotenuse. And that's what we're trying to solve. So you're definitely going to want to use that side. And then, let's see, left over is adjacent. There's no information there, so we don't want to use that. So for this one, you're going to want to use whichever SO, CA, or TOA uses O and H. And then once you finish solving, you should have the length of the water slide, no problem. A garage is 8 feet above street level. The driveway from the street to the garage is about 45 feet long. Find the driveway's angle of incline. So I went ahead and made the triangle a little bit bigger. They already labeled this as 8, and this is 90 degrees if it were actually perfect, which it's not, but it should be. This is what we're trying to solve for, x, and this is 45. So if you label it, this is the angle, straight across is the opposite side, 90 degrees down here, straight across from that is the hypotenuse, and then left over is adjacent. So that's all I'm going to do on this one. I'm going to let you finish setting it up and solve for x. You are finding the angle, so you're going to have to end up using the inverse on this one. Don't forget that. When you're all done, you will have the driveway's angle of incline. Best of luck to you, and this concludes our lesson 12.2.